Yeah, we already talked about the location being unavailable. There is really no support for this in the simulator. Core location is not something you can test on there. There's no GPS on the computer. There's Wi-Fi, but there's no cell, so it's just not going to be there. You pretty much have to test this on a real device if you want to be using core location. All right, so that's kind of how you get a broad sort of global overview of where you're at. But what if you care about something much more local? So you've got your device in your hand, and you want to let the user drive, tilt their device left and right to be like a steering wheel, or anything else that you might want motion interaction with the device. So that's what the accelerometer is really going to get you, and also kind of the compass, which we talked about already, but that one's over in core location, the accelerometer's over here in UIKit. Yeah. So what's the accelerometer going to do? What is it? Well, it measures changes in force. So as the device moves, well, let's start out stationary, right? So you're holding your device in your hand, up and down, kind of like this, right? There's a constant downward force right now, right? The force of gravity. And the accelerometer will report that as 1g pointing downwards. If the user then turns their device to the side a little bit, that's going to change, right? Now there's going to be acceleration in two directions. And it's basically, there's a device in the phone that is measuring this acceleration. So as you're actually tilting the phone, you're tilting the device, and it figures out the new acceleration and what direction you're pointing in. So that's just if you're holding it still. But if you start moving, then it's actually going to be able to report the movement both horizontally, vertically, and back and forth in all four orientations, or 6. So yeah, what are you going to do with this? Well, the most basic use case, and you've seen this all over the phone and the iPod already, is to detect that the user has rotated and rotate the UI from portrait to landscape so that it's always face up in whatever direction the user is holding their phone. You don't have to do too much with the raw accelerometer data in order to do that. In fact, you don't have to do anything with the raw accelerometer data in order to just do these rotations. So we'll talk about some of the APIs for that. And that's the most basic case, right? So users got their phone, they're in iTunes, they've got their now playing screen up, they turn the device to the side, and now all of a sudden they've got cover flow. The UI has changed to be something that's appropriate for the new orientation that the user is holding the device. So it's pretty raw, right? It's either I'm up or down or left or right. It's not using the instantaneous feedback that you can also get. So we'll get into that a little bit later. But this is interesting just on its own. So we can basically figure out the physical orientation. Is it flat on the table? Is it flat upside down? Are we holding it up and down? Is it portrait? Is it landscape? We can figure out those things. There's kind of a duality of things here. It's a little weird. So bear with me for a second. You've got two basic concepts of the orientation. Oops, and I just flipped to the wrong place. There we are. So you've got the physical device orientation. So in this case, let's say I'm holding it like this. I'm portrait. If I'm holding it like this, I'm portrait upside down. And if I'm doing this, I'm now landscape right because I've taken the device and I've rotated it to the right. So I'm now device orientation right. However, there's a second thing here, which is the user interface orientation. So user interface orientation is basically the status bar orientation, and it's what's happening on the screen. So just because I've turned my phone sideways doesn't necessarily mean that the user interface has changed, right? Some apps don't support rotation. So if I start out in device portrait and then rotate to device right, I'm now at user interface left because the device has moved to the right, but the interface has moved to the left to accommodate. So it's a little weird and kind of odd at first, but if you stop and think about it for a second and just look at it, it starts to make some sense. But so there's two slightly, I mean, they're directly tied together, but not necessarily, well, they're not really directly tied together. There's these two things, the device orientation and the interface orientation, and they may not be the same, and in fact, in a lot of cases are not. There's also more device orientations than there are interface orientations. Device can be just flat on the table or flat upside down. There's no corresponding interface orientation for that because that doesn't really mean anything. The interface orientation is either portrait upside down, landscape left, or landscape right. The device can be any of those plus flat on the table and flat upside down. So this is kind of an old example. It's not true in iPhone OS 3.0 anymore, but easier to explain with this than with some other things. So if we go into the Photos app and open up one of these albums and then actually go in and look at one of the photos, we're now in both device orientation portrait and user interface orientation portrait. If we rotate the device, the photo is going to rotate, right? So the device is now in landscape left, but in iPhone OS 2.0 and earlier, the Photos application actually didn't rotate the user interface. So the interface actually stayed as portrait, even though the device was now landscape, and even though some of the picture actually rotated. So anyway, all these things are kind of independent, and you can control them independently in your own application. Well, obviously you can't control the device orientation in your application, but yeah, the interface orientation you can. And Safari does the same thing, except in Safari it actually rotates the interface. And Photos does now as well as Mail and Notes and pretty much all the apps on the phone in iPhone OS 3.0. So OK, that was kind of a rambling tangent there. Let's get back on track. So let's get the physical device orientation, right? That's the way the user is actually holding their phone. So you do that using the UI device class. You usually want to start notifications by calling begin generating device orientation notifications. Again, we've got these nice long names, so you have to type a lot, or autocomplete. You can start finding out about these things happening by registering for the UI device orientation did change notification. This will get called. The granularity is basically the user has actually fully rotated their device, so it's not called a lot unless the user's like moving back and forth constantly. So it'll be delivered to registered observers. I think we've kind of talked about this briefly. There's the NS Notification Center, which is the class that's used to register for notifications. I don't remember if we really got into that. So if we didn't talk about it yet, or you're not real familiar, does that sound familiar to anyone, actually? Heard about it? No? All right, well, there's a class called NS Notification Center. And you can use that to register for global sort of app or system-wide notifications. And one of those is going to be this UI device orientation did change notification. You can find that in Foundation in nsnotificationcenter.h. We're not going to get into it too much, but there's really only one method you have to know about there. Well, two. There's register for notification, and you specify an object and a method to be called for that when that notification happens. And then there's unregister, which lets you unregister for unregister for notifications. And then finally, we've got the end generating device orientation notifications, which stops generating these. The interface orientation stuff is, there's kind of two ways to get at that. The UI application class defines the status bar orientation property. And this is always up to date based on where the status bar currently is on the screen. So if you're holding the device in portrait and the status bar is up top, then status bar orientation is UI interface orientation portrait. If the status bar is left and one of the orientations, it'll be landscape left or landscape right. That's on UI application. It defines the orientation again, not the device orientation. So it's the orientation of the interface, which may not be necessarily tied to the orientation of the device. That's kind of, usually you'll use that to get the orientation. You very infrequently will use that to set the orientation. UI View Controller actually provides its own concept of interface orientation, and it updates the application's interface orientation for you. And there's this, actually, it's pretty easy to use. There's a method that you can override in your UI View Controller subclass called should auto-rotate to interface orientation. And it takes one parameter, which is the interface orientation, and the return value is a bool, either yes or no. So if you implement this method, you don't actually have to worry about any of those device methods we just talked about, and you don't really even have to worry about the UI application method. You basically just implement this one method and return yes for any orientations that you want to support. And UI View Controller takes care of the rest. It rotates your interface for you. It updates the status bar location. It handles all that. So you just implement this one method. It's going to rotate everything. If you've set up all your springs and struts in Interface Builder on your view controllers, your view controller's view, things will even relay out correctly and move around. You may actually need to do some more on your own if you actually want significantly different layouts in portrait and landscape. But for the most part, View Controller takes care of all the specifics of this for you, so you don't have to do too much at all. There's a new thing in iPhone OS 3 that lets you detect shake. And shake, by default, is used for undo and redo on iPhone. You can override that yourself in your own applications to mean something else if you want. There's a standard event that gets called that basically guarantees that our definition of shake is consistent across everyone's app. So if you want to say that you have to shake to shuffle in your card game, it'll be the same shake motion to shuffle that it would be for shaking in any other application. So you probably want to take advantage of our shake event rather than try and write your own based on the raw accelerometer, just because then users won't get confused why what they think is a shake in one app isn't a shake in another.